On October 29th, 2025, as 3I/ATLAS reached perihelion, astronomers witnessed the impossible. The comet turned blue instead of red. NASA's data confirmed a sudden spectral shift no known comet model could explain. Was it extreme chemistry, radiation damage, or evidence of something never seen before in our solar system? One thing's certain, this changes everything. Let's dive right in. The moment 3I/ATLAS brushed past the sun, everything we thought we knew about comets began to unravel. Instead of fading into the familiar orange-red hue of heat and dust, it flashed blue, a spectral, electric blue that cut through the darkness like a pulse from another world. And in that instant, telescopes across the solar system began to question reality itself. At first, astronomers did what scientists always do. They doubted their own instruments. Maybe a calibration error, maybe solar glare confused the sensors. But as data streamed in from NASA's SOHO, STEREOA, and GOES-19 satellites, each confirming the same thing, the doubts turned into disbelief. The signal was real. 3I/ATLAS had somehow turned bluer than the sun itself. Comets aren't supposed to behave this way. When ice sublimates near the sun, blue light scatters first, leaving the object warmer in color. But 3I/ATLAS did the opposite. Its brightness surged, its spectrum shifted, and its water loss skyrocketed 40-fold in less than a month. 5.7 times 10 to the 28th power water molecules per second. That's a fire hose of vapor blasting into space, enough to fill a swimming pool every millisecond. And yet, the most shocking part wasn't how bright it became. It was what wasn't there. No dust tail, no glowing arc trailing behind it, like every comet we've ever seen. Just an elongated, ghostly blue form, moving in silence. Scientists tried to explain it. Some proposed that the comet's surface had been insulated by a layer of frozen carbon dioxide. That layer, they said, might have shielded the water ice below until it suddenly broke apart under extreme solar radiation. When it did, the ice underneath would have vaporized explosively, releasing vast plumes of gas, bright, clean, and dustless. It was a solid theory, but it didn't quite fit. The timing was too perfect, the intensity too precise. As one researcher put it, it's like the comet knew exactly when to ignite. To understand that, we need to look deeper, literally. Because 3I/ATLAS isn't a normal visitor. It didn't form in our solar system. It came from the void between stars, carrying the scars of that endless journey. The James Webb Space Telescope observed something remarkable, a surface crust heavily altered by cosmic radiation. For billions of years, high-energy galactic rays, particles born from exploding stars, bombarded it relentlessly. They didn't just weather the surface, they rewrote it. Molecules broke apart, recombined, froze again into strange crystalline forms. Dr. Roma Maggiolo and her team at the Royal Belgian Institute for Space Astronomy simulated this process. Their models showed that cosmic rays could penetrate up to 20 meters deep, transforming everything they touched into a hardened, carbon-rich shell, a radiation-forged armor. That crust, she said, is no longer the same material the comet started with. It's not a fossil from another star system. It's a new hybrid, a survivor of interstellar space itself. That realization changed everything. Because if the surface has been rewritten by the galaxy, what's still preserved beneath it? Could the core hold the untouched chemistry of another world? An ancient fingerprint from a star that no longer exists? NASA and ESA teams believe that beneath the irradiated crust might lie pristine material, unaltered for over 7 billion years. If they're right, 3I/ATLAS could give us the first real sample of chemistry from a completely different solar system. But there's a catch. We don't have much time. At over 130,000 miles per hour, the object is already racing away from the sun. Within weeks, it'll fade from view, forever. And yet, the more we study it, the more its motion feels deliberate. Its path isn't chaotic or curved like a local comet's orbit. It's clean, steady, unnervingly linear, as if unaffected by gravitational nudges that should have deflected it long ago. It's moving through our system like a message passing through noise, indifferent to everything around it. That's when the scientific debate split wide open. One side insists this is still natural, just a comet with unusual chemistry, strange but explainable. The other side, led by voices like Professor Avi Loeb from Harvard, isn't so sure. Loeb formally requested NASA to release all observational data, arguing that we can't rule anything out. Not yet. Because the more you look at 3I/ATLAS, the more it behaves like something designed for endurance. Its crust acts like armor. Its mass, over 33 billion tons, is enormous for a comet. Its reaction to sunlight is abrupt, not gradual. Its brightness surge triggered at an exact threshold, almost like an activation signal. If nature produced this kind of precision by accident, it would be one of the rarest coincidences in cosmic history. Imagine building a spacecraft meant to survive for billions of years, drifting between the stars without fuel or maintenance. You'd need it to endure radiation, impacts, and deep space cold. You'd want it to stay dormant until it encountered a new star, and only then awaken. That's exactly what 3I/ATLAS seems to have done. The irradiated crust, perfect shielding, the sudden burst at Perihelion, a natural trigger, the lack of dust, a surface too stable to crumble. No one is claiming it's artificial, but if you were designing a probe to outlast civilizations, to sleep across epochs, this is exactly how it would look. Maybe it's coincidence. Maybe it's just physics. But it's hard not to feel that 3I/ATLAS is performing rather than reacting. Not everyone sees mystery in its design. Some see tragedy. Dr. Suzanne Falsner from Germany's Jülich Research Center believes interstellar objects like 3I/ATLAS are more than wanderers. She calls them planet seeds. Her computer models suggest that when young stars form, they capture countless interstellar objects. These bodies, already hundreds of meters wide, can act as the gravitational cores around which new planets grow. In that sense, 3I/ATLAS might be the remnant of a world that almost existed, a building block ejected from its birthplace before it could gather mass, condemned to drift endlessly between suns. It's a haunting thought that we're watching not just a comet, but the memory of a planet that never formed. Now, as it moves away, astronomers are in a global race to collect every photon, every spectral reading before it disappears. Even the Mars rovers, Curiosity and Perseverance, captured images of its faint glow from the Martian sky. Those datasets haven't been released publicly, but rumors among researchers hint at something unexpected: plasma waves forming geometric patterns around the comet's coma. If that's confirmed, it would mean 3I/ATLAS isn't just reacting to sunlight, it's interacting with the solar wind in ways no natural comet should. But until NASA releases everything, speculation will continue. And Loeb's call for transparency grows louder. If there's nothing unusual, he says, then sharing the data only strengthens the science. But if there is, then humanity deserves to know. Here's the part most people forget. We've only ever studied 3 interstellar objects. Oumuamua in 2017, fast, silent, and strangely shaped. Borisov in 2019, seemingly normal yet chemically distinct. And now 3I/ATLAS, the first one to change color before our eyes. 3 visitors, 3 anomalies. That's not coincidence. That's a pattern waiting to be understood. Maybe they're all natural. Maybe the galaxy is simply more diverse than our imagination. But what if even one of them isn't? What if, drifting among the billions of icy rocks between stars, a few are messages, objects built long before us, sent out to wander until they meet another civilization capable of noticing? It sounds dramatic. It sounds impossible. But so did a blue comet. Until it happened. At its core, this isn't just about data or chemistry. It's about humility. 3I/ATLAS reminds us that even with all our telescopes, all our equations, we're still students of a universe infinitely older and wiser than we are. Its blue light might be nothing more than sunlight scattering off exotic molecules. Or it might be something far more profound, a sign that the cosmos still has secrets that refuse to fit inside our models. Either way, it speaks to us. It challenges us to look deeper, to ask harder questions, to admit that we don't have all the answers. And maybe that's the most important part of science, to keep the curiosity alive. Because somewhere out there, beyond the heliosphere, countless other objects like 3I/ATLAS are drifting silently between the stars. Some may be ancient debris, some may be the first sparks of planets, and maybe, just maybe, one of them carries a story written long before ours began. So what does it all mean? 3I/ATLAS didn't just turn blue, it broke the rules of how the universe is supposed to work. For some, it's just chemistry under pressure. For others, it's a sign that interstellar space holds secrets far beyond our imagination. But one thing's undeniable. Moments like this remind us that discovery doesn't end at explanation. It begins there. As 3I/ATLAS fades into the dark, the real question remains. What else is out there, waiting to be noticed? Could the next visitor reveal the missing piece of our cosmic story? If you want to follow what happens next, the data releases, the hidden signals, and the next interstellar mystery, make sure to like this video, share your thoughts in the comments, and subscribe to Galactic Breaking News. Hit the bell because the universe never repeats itself, and the next revelation might already be on its way. On October 29th, 2025, right at Perihelion, the interstellar object 3I/ATLAS didn't just brighten like every comet before it. It exploded. NASA's solar observatories caught the outburst live, and what followed shocked their entire team. The data showed something no comet should ever do. Patterns that defy physics and maybe common sense. What exactly did NASA see next, and why are scientists still silent? Let's dive right in. The first burst of data came in quietly, almost too quietly for something this extraordinary. At 5:17 UTC, October 29th, 2025, NASA's monitoring systems lit up. 3I/ATLAS, a frozen traveler from another star system, had just reached its closest